is going to be on the amines again, and this time it's the amine reactions. So we can produce amines directly from haloalkanes. The mechanism for this is nucleophilic substitution, and the nucleophile is ammonia, and I've specified that there is a lone pair there. For some reason a lot of people forget, so there is a lone pair there. Okay, so trying to get this back into a nice width. Okay, so the amine that we get depends on which of the reagents is in excess. So is it the ammonia in excess or the haloalkane? So when ammonia is in excess, a primary amine is formed. And so I've done the reaction mechanism for this. Hopefully by now you will be good at your mechanisms from AS. If not, I'll go through it anyway. So the ammonia acts as the nucleophile, and just to reiterate, a nucleophile is an electron pair donor. So this will attack the partially positive carbon atom. This is partially positive because the bromide is very electronegative compared to the carbon atom, so it withdraws the electron density from their shared bond, the covalent bond between them. So obviously that exposes the carbon, giving it its partially positive charge. So our nucleophile will attack that, but a carbon cannot have 5 bonds. So because the ammonia is now bonded to the carbon, the bromide is lost and it takes its electrons with it because they were towards the bromide anyway due to its electronegativity. This then releases a bromide here. But I won't put that in right now. So getting that highlighting back. The next step is that we have our substituted species, should I say, but the ammonium, which is on the end, doesn't like to be a plus charge. So what it does is one of the hydrogen atoms, I chose this one to be the kind person to donate, loses its electrons, which go back into the nitrogen, releasing this hydrogen to be out. This will form HBr, because obviously before we had the bromide ion, so the bromide ion will react with the H+, forming HBr, so clearing that. And what this does is it forms our final product here, which is our amine, and this is a primary amine because only one of the hydrogen atoms has been replaced with an alkyl group. And of course we have our lone pair here, which will be important in the next part of the video. So using an excess of ammonia, to reiterate what I've just said, means that the lone pair on the primary amine can't further react with the haloalkane. So the reason this is going to be important in the second is because this lone pair here, well, if you think about it, if the haloalkane was in excess, what's to stop this reacting with that, acting as a nucleophile? The answer is, if your haloalkane's in excess, there's nothing stopping that from happening. So what actually happens is when the haloalkane is in excess, the reaction will continue up until a quaternary amine is formed. And this is because the lone pairs on the amines will cause them to act as nucleophiles. So I'm not going to go through this in particular detail because it's literally the same mechanism each time. But let me just say that this is your haloalkane from the beginning. This reacts in the nucleophilic substitution reaction with ammonia to form the primary amine, which I've just gone through, releasing HBr. Because of this, this can then react as a nucleophile, which I'll show here. So this nucleophile reacts with our haloalkane, which was in excess. Same reaction mechanism, so same intermediate. Well, it's not the same, because obviously it's got that, whereas here it had them. But you understand what I'm saying, it's the same mechanism, but this time we form a secondary amine because 2 of the hydrogen atoms have been replaced, plus HBr. This then, because of the lone pair still there, reacts with the haloalkane still. this same intermediate step finally forms a tertiary amine. Finally then, this lone pair here can further react, and I've just wrote it like this for ease of use, and this will finally form a quaternary amine, which does not have a lone pair, so that's where the reaction ends. And this doesn't form HBr either, because no hydrogen was released. And just in case you've not watched my other videos yet, the quaternary amine is known as a quaternary ammonium salt, and they're used for their cationic surfactants in fabric softeners. So finally then, a bit more easier things to understand, we can also produce amines from nitriles, and to do this we reduce the nitriles, and we do this using hydrogen and a nickel catalyst. Similarly, we can produce aromatic amines, so phenylamines, by reducing nitrobenzenes, and again we do this using hydrogen and a nickel catalyst. The reaction where we reduce nitriles is often favoured opposed to the reaction above of using excess ammonia to form a primary amine, because this can't always be guaranteed to form only primary amines. It will also react to form, well, all of these. However, nitriles will always form a primary amine, and we can form nitriles, if you remember from AS, from haloalkanes by reacting it in a nucleophilic substitution reaction with hydrogen cyanide in ethanoic conditions. So that's a bit of kind of stretching your knowledge, but it may help in an exam. So that's all you need to know for the amines. I hope that helped.